we go. Okay, so here, when we compare this one to this one, that's why I was saying this has the 2 roots. This one also has the 2 roots. X squared minus 9 also has the 2 roots. So if you look at that and go, and don't forget that it's plus minus 3, you don't have to show this step. You can go straight and go all the way over here and just give it the roots. But you got to look and say, if it's squared, it's telling you, wait, are there 2 roots? Right? And so don't skip this step if you're going to do it wrong, but you can if you're like, but that's just x squared equals 9, which I know is plus minus 3. Okay? So if you don't need to fully factor, I need the x-intercept. So from here, I know it's 0, plus minus root 3, and plus minus 3. There you go. So we've got 1, 2. I got 2 from here, 2 from there, and 1 from there. 1, 2, 3, 4, 5. So I've got my 5 possible roots. And when we talked about the other day, how many possible roots are there? Possibly up to 5. Yep.
If we see one of the x-intercepts is 0, do you not use this to find the y?
Nope. And exactly, your y-intercept right away is that. So when you do more and you know more, it's y equals 0. You don't even have to show me because it'll be on your graph. So when I look at your graph, good point, when you know it's 0, it's already your y-intercept. You don't have to find it. When I look on your graph, all I want to see is the 0 one time. You're not doing it twice. Yeah. Right? So the more you know, you kind of go, oh, I can do this a little faster sometimes, which is nice. So we're going to do a tiny graph here. I don't need a lot of room here. And then on the side, I'm going to do the leading coefficient stuff. Again, you don't have to list it. I like to because I find that it just reminds me of what I'm trying to draw. So I'm going to go leading coefficient is, okay, so now looking. I need to, oh, this part, watch out. When the x's are forwards and backwards, which we frequently do, there's an x here. There's a negative x squared. Look at the sign in front. And there's a positive x squared. And you look at the coefficient in front to see if that's negative as well. Okay. So then that's positive, right? Positive. Negative x squared, so that'll be negative. It is negative, right? Because it's a negative coefficient, so positive times negative, and that's a positive. So it will be negative. Does that make sense? All right, so I'll get x times negative x squared will give me a negative number. My degree, 1x, 2 more x's, so degree looks 5 to me, which is odd, so that means down. So I know my end behavior starts up here and heads down here. And I'll do my roots. So exactly, x-intercept, y-intercept are 0 for sure. And then positive negative root 3 and positive negative root, 3. So we've got, again, I don't care about the spacing. So somewhere, right, again, we're just getting the shape. Shape only. So we're starting up here. Okay, which ones are linear? Are they all linear? Oh, they are. 1, 2, 3. They are one of each, so it's linear, 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 linear. All of them are linear. So you're just going to go through and just go right through. Okay, so let's start at the top. Again, if you're missing one of these, like if you forgot the plus minus on one of them, you'll never get it to go through and face the right way. You'll be facing the wrong way. Unless you make a bunch of mistakes, in which case, yeah, sometimes a bunch of mistakes works itself out, yeah.
The root 3 is linear because you evaluate for the x squared, right?
Yeah, because I've got one of each. So if I've got a root 3 and a root 3 2 times in my answers, then it becomes quadratic. Then it becomes order 2. Yeah, because I only got the answer once, then that's why. So it's going to be negative root 3. I got that once. I got a root 3 once. I got a 3 once, and a negative 3. So how many times was it a root? Yeah. All right, and I'm going to try to draw it. So we're going to go, this should be hopefully easy. So it's through, 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 through. And again, try not to make it look cubic, right, or anything else funny happening. And that should be it. Whoosh and whoosh. Okay, I hope there's something happening on this one. Otherwise, I've lost my mind. Why did I do the question? Okay, so here, 9 minus x squared. Yep, so right away, if you want to just say, I know I got the plus minus root 3, that's good. Here, you got 2, negative 2. Here, though, you got 9 minus 3x. I can factor out 3, and there's 2 of them, so I'll fix that in a second. So up to you if you factor it or not. I think I'm going to try the factoring way, and if you didn't, then I'll explain what to do if you didn't factor it. But you should get the same thing. So -4. This I'm going to get 3 minus x, 3 plus x, like that. Here I have 2 of this guy, so order 2. And here, do this. So squared stays there, and I know I can common factor 3 out, and I get 3 minus x. But, sorry, how much where? So if I take out, so if I take out the positive 3,
You take a negative 3.
yes, yeah, so then it would be positive x and you'd flip it, but I didn't flip it because this guy's here already, right? So you can flip it, yes. So the question is, if I took out -3, it would change the order, and yeah, that's what I was saying about, you know how things feel backwards? You can switch them all so they're facing the same way, because sometimes you're like, I feel weird, I'm comparing a x minus 3 to a 3 minus x, I forget which one's which. So if you want to just have them all facing the same way, so these guys can compare, or x minus 3 the other way, right? So do whatever it helps you, right? You don't have to, but you want them in the same order, because otherwise you go x minus 3 and 3 minus x, are they the same or are they not? And it gets confusing. So I'm purposely leaving it this way because I can see they're the same. So if you're solving each root separately, so this is the thing I want to remind you of. If you're solving each one, you have to count how many times you get 3 as your root. You can't just say my x-intercept is. So this is important because you need to know how many times you know the order of it. So if you don't do it this way, so if I have 3 2's, that would be 2 times 3, so 9 times 4. Can I bring that in front, make it 36? I'm just going to put the number in front. Okay, that helps me clean it up. Then I have 3 minus x, 3 minus x. How many 3 minus x's do I have? 1, 2, 3. I have 3 of them. Then I have 3 plus x, and I have there. So I have order 3, right? So order 3, order 2, order 3, 2, 1, and then with a negative in front. So if you just do the roots, you just have to remind yourself how many times you're getting the root 3, not root 3, the x-intercept 3, not square root 3. Every time you get the answer x-intercept 3, you have to count it. You have to go, I got that 1, 2, 3 times. Then you know it's order 3. Okay, so that's why. So here, we're good. We got it 1, 2 times. We got an x, 1 of each. Be careful when you're jumping to the roots, because if you jump to the root, you won't catch the orders. So both ways are good. When it becomes more complicated, I suggest trying to draw it out factored, right? Because you tend to sometimes lose an order. If you don't, that's fine. But you need to calculate how many of that factor you got. I need to know it was order 3. And then do it again. Go 1, 2, 3, 4, 5, 6. How many x's should I see here? 1, 2, 3, 4, 5, 6. Did I account for them all here? Yes. Right, so don't drop an x somewhere. Make sure you didn't forget a factor somewhere. If you do a common factor of x, you want to double check that you didn't forget to write something down. Okay, now, y-intercept. Oh yeah, I got to calculate this one then. Oh, x-intercept, I haven't done it yet. So x-intercept. X-intercept would be nothing here. I got a 3, a -3, and a -2. My y-intercept is going to be f at 0. So I got -4 times, that's 9 minus 0. This is going to be 2 squared. If I put 0 in here, 9 minus 0, so it'll be 9 squared. And I got, ooh, I'm really sorry. Sometimes our numbers can be funny because I choose the factors, but I can't control the fact that my y-intercept is negative 11,664. So please don't do tick marks on your y-axis to indicate negative 11,664. I mean, up to you. No, it's not up to you. Just don't do it. Just don't try to draw negative 11,000. Whatever number happens, happens, especially when I start to get bigger numbers. Like it didn't look big here, and look what happened to my y-intercept. So I apologize. Yes, the numbers will be crazy sometimes. But those factors were all good, right? I got 3, 3, and negative 2. And then the y-intercept went crazy. But that's good. It's all good because of the exponential, right? It grows fast. Okay, so we got that. So I'll draw my axis. Again, we're not drawing negative 11,000 tick marks. We're just drawing the shape. Here we go. And on the side, okay, we're going to do on the side here, my leading coefficient is, oh geez, this is going to take a bit of time. So as soon as I have 2 of that, it's positive, right? Oh, and I have 2 of that one, so it's positive. So it's being positive. This one's negative, though. That's negative x squared, not negative bracket x squared, right? So that's a negative with another negative. Does that make sense? So all squared is positive. All squared is positive. These guys are going to get me my leading coefficient of positive. Yes? We okay with that? So opening up. What about my degree? I have 2 x's, 2 more x's, so 4. 2 more x's, so 6. None. Degree 6, we good? 6 x's, so 6, which is even, so it's this way. So my end behavior is up here, and then draw your roots, which isn't even that bad. So it's going to be negative 2, negative 3, and a 3. And my y-intercept of negative 11,664. All good, all good, all good. All right, so we're going to go 1. Okay, wait. Order 2. So I need a turning point at here. Order 3. And cubic looking at 3. Yes? So at 3, it's cubic looking, and here I bounce. Here we go. Wish me luck. 1. Bounce. Come back through, turn, there we go. And then fix your dot if you need to move the dot over, which I did. And so I got the cubic shape, cubic, quadratic shape, parabolic shape I mean, and erase, erase. Oh, sorry, and label this negative 11,664. No tick marks. Questions, clarification? Okay, now we're into the backwards question. So this example and the next example are backwards. This one I gave it in words and I described it, and you're writing the equation. And then the next page, it's going to be I drew it and you're going to write the equation. So it's basically the 2 other versions we have is that here I gave you the equation, you're drawing it, now I'm going to describe it or give you the drawing and you're going to go backwards. So here, write the equation of a quartic. So highlight, quartic, right? I need you to know that word. Quartic means degree. What's quartic? 4, yes. Degree 4 has zeros at negative 2, 3. 3 has an order of 2, so we know that'll be squared, and 2/5. The function has a y-intercept of 6. Okay, so we'll fix that through that. So for each one of these, we know that if it has a 0 here, that would get me an x plus 2. Does that make sense? This one here tells me that this is going to be x what? If it equals 3, minus 3, is that okay? And it's squared. Right, so if it equals that. We can usually do that in your head. Right, people go, okay, I can get that. This one, the 2/5, sometimes is a little harder to see. Sorry, it got faded here, but that's a 2/5. Okay, that's a little harder to see. So you can drag that to the side. And what I'm saying is that x equals 2 over 5, right? I'm saying that's what my x-intercept was. So grab that guy, and I want you to unsolve it. So we're unsolving it. So I want the 5 to be back with the x. So we're going to unsolve it and make it equal 0. So we're going to bring the 5 back up, and we're going to go 5x equals 2. And we want it to equal 0, and bring the 2 over. So 5x minus 2 equals 0. So my factor is this. Okay, so that's what we want. Now, these guys, again, you guys have done so many of these, sometimes you do that in your head and you don't realize what you're doing, but that's what you're doing. You're unsolving it. You're bringing the 3 over, you're bringing the negative 2 over. So you're unsolving it. You don't have to show this if you don't want, but yes.
So why is it my factor x minus 2 over 5?
X, it can be. We don't want fractions. So whenever you factored, like, we never did the fractions. So yes, x minus 2 over 5 is that's it. So the other way is x minus 2 over 5 is my factor, but I don't want this fraction to be your factor. So it's the same thing. So I multiplied the whole thing. And remember, since it equals 0, I'm multiplying the whole thing by 5, so that's where you get the 5x minus 2. So both of these get you the same root. Yeah, it just, we don't want fraction form. Yeah, but it means the same thing. Yeah. Yep, so you can start with that. If it's faster, you go x minus 2, 5, but multiply both sides by 5, so then you get 5 equals 2x. So yeah, same. Okay, but not fraction form, so we usually want integers. Yeah, so so integers. That's why. Okay, so that's correct, but we want integers. So do not leave. I'll say do not leave like that. Does that make sense? So it's right. It's just don't leave it like that. So if you fix it so it's integers again. All right. What else? What else do we need? Okay, and so we've got these. We know all the factors. We know it's quartic. Does that make sense? Degree 4. 1, 2, 3, 4. We're good? So we got them all covered. Now, this is what you're going to write down, and we're almost done except for this y-intercept of 6 that we have to fix, right? So this part here, we're not done this, y-intercept of 6. So we're going to go f at x, or y equals, I prefer y, f of x rather than y, please, since we are so mature. We're going to put a. I don't know what the coefficient is, so that coefficient is going to stretch it or shrink it or move it so it can hit the y-intercept. So that's the unknown part. So you're saying, for instance, like you have a parabola, you know where the roots are, but you don't know if it opens up or down or how much to stretch or shrink it by. So this is the a part that's missing. So this y-intercept will help me get the a. I can put everything else here, so x plus 2, x minus 3 squared, and 5x minus 2, like that. And this a is going to be solved by this. So we're going to use the y-intercept of 6. This gives me 0, 6, and we're going to sub that to find the a. Okay, you don't have to write this, but just that's what we're finding. So you're going to take this, we know it's 0, 6, because it's y-intercept of 6, sub it into here to find your a value, and then you're done. Okay, so let's do that. So we know it's 6 is the y, equals a is what we're solving for, and x is 0. So that would be 0 plus 2. You don't have to show me the 0, but I'll show you just for our notes. You can skip this part, 5, 0 minus 2. You can go straight to this. So if you want to, you can go a, and then just show me 2, negative 3 squared, and that's 0, so negative 2. So 6 equals, what's that, 9 times negative 4, so negative 36a. Divide both sides by negative 36, and we get whoops, sorry. And that'll be negative 1 over 6 equals a. So therefore, f of x equals negative 1 over 6. And this will be, yes, that can be a fraction. Okay, because we can't do anything about that, otherwise you're going to get a repeating decimal. So it'll be, or improper answer. So we're going to leave that as a fraction, please. And then everything else like that. Yes?
What if you use the x minus 2 over 5 in your
Yeah, wouldn't it get you a different answer?
Yeah, but then your factor would be different. Wait, would it get you a different answer or not?
Because you're multiplying by different, it wouldn't be negative 2, it'd be negative 2 over 5.
Negative 2, yeah, so then that'll change that. But your factor is also different, right? So that will change that. So that's why. So don't leave it in that form. So that's why I said don't leave it in the fraction form. They don't like usually fractions in a factor, right? The fraction in the front, there's nothing you can do about it, right? But here, if you leave that, that'll change that because your two factors, yeah, it's going to be affecting each other. No. But when you, yeah, it's all, no, but when you put the numbers in, your t chart will be the same, right? So when I put in 0, you'll still get the same number. It'll balance. This will balance this. Right? So that, since this is changing, it'll balance this number. And so you'll still get the same values, like the same coordinates for it, because if this changes, it affects that, and they'll balance each other, and you get the exact same graph, but this would change with that. Yeah. But the general rule is that we don't like fractions here. Here, yeah, we have to accept it because there's nothing you can do about it. But in the factors, they don't like fractions there. Okay? Yeah, and you'll get the same graph. Yeah.